Hi, this is Mr. Gagnon again, and we're going to talk a little bit more about vectors. And this time we're going to look at a situation where we have an airplane that's traveling across the country and is experiencing a crosswind, which is going to really attempt to blow the airplane off course. So the pilot has to learn which direction he or she must head in order to negate the crosswind. Okay, so looking down at it, we'll say that the airplane, here it is. Okay, forgive my drawing; it's not going to be the best. Looking down at an airplane. Okay, here it is. Okay, this airplane here is looking down at it. It's flying, we'll say, eastward. Okay, and so let's say that we have some numbers here. We'll say that we have the plane is flying at a velocity. The velocity of the plane is 200 kilometers per hour due east. Okay, let's say that we have, it's a pretty windy situation, and let's say we have a good average headwind. Well, no, not a headwind. Let's do crosswind. Let's say we have a good heavy crosswind pushing the jet off course to the south. So it's coming from the north, heading to the south. And let's say it's a pretty windy day, and the velocity of the wind is, let's say, 35 kilometers per hour south. Okay, it's headed south. So what we do with this type of problem is we need to add these vectors up. And from the previous problems, we know that we add vectors from tip to tail. And it doesn't matter which way we add them, because these are commutative. Okay, so my question would be, what angle must the pilot aim the plane in order to end up directly across from where he wants to be? Okay, so now that's a tricky question, because we're going to find the angle that the plane wants to go off at with the crosswind. So the plane is going to want to be pushed down. So the pilot has to direct the plane in the northward direction in order to negate the southward push of the wind. So let's do it. Let's add up the vectors. So if I draw a picture of the addition of vectors, I have a 200, and again, it's not to scale, that's okay. And then I have a 35 attached to that, 35. So if I go ahead and find out what the resultant velocity is, I'm going from here to here, beginning to end. This is my resultant, so we'll call that R. The resultant equals the square root of 35 squared plus 200 squared. So let's do that math. Okay, so the resultant ends up being 203 kilometers per hour. So it sped the plane up a little bit, but it put it off at some angle here. And again, this is not to scale, but it's so I can actually fit the angle in here. So that's the resultant speed. But I need to know the velocity. Okay, we'll put that over here at some angle. Okay, so to get that angle, we are going to use our trig knowledge. Here's the angle. I've got an opposite, and I've got an adjacent. So tangent of the angle equals 35, which is the opposite over the adjacent, 200. So the angle will be 35 over 200 divided by tangent. Okay, so I'm going to go ahead and plug that in the calculator to get that angle which the plane is being pushed off at. So let's see what we have here. Okay. The angle that I come up with is a 9.9 degree angle. So the plane is going to be pushed off, especially if it's going straight, it's going to be pushed off from this wind at an angle of 9.9 degrees. And then I'm going to figure out in what heading it is. So I draw my coordinate plane to help me. It's south of east. South of the east line. Okay, so here's the east line. It's going south of the east line. Now, the question isn't over because I asked what direction the plane must be heading in order to end up directly straight across the country or whatever the destination is. So if the plane's headed off at this angle, if it heads straight, it's going to have to adjust its bearing. It's going to have to push itself this way, okay, at the opposite angle at which it would have gone at if it headed straight. So the answer right here would be the angle of 9.9 degrees north of east. So here's our final answer, 9.9 degrees north of east. The plane has to head in order for it to end up down here. Okay, because it has, it's getting pushed by a wind, and this is the direction the pilot must go at in order to get to his destination or her destination. Okay? That's another example of two-dimensional vector addition. All right, thank you and have a great day.